Oh, don't forget the microphone. Doop, unmute. So, okay. Do 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 do. Hello. Glenn! Here we go. Well, I'll just hop in and say hello then. How are you? You hear me okay? Let's see. Testing. My mic looks like it's working. Wait. Yeah, that's definitely working. I can see it happening. How are you? It's been so long. Just moved and I'm settling in. Oh, wonderful. That's good to hear. Um, How's business? How's the business side of things? How you feeling? I have wine tonight, by the way, so it's a very fancy evening. This is, what do I have? There's a fantastic new wine that I've discovered. It's my final week at work, but I'm sticking around part time. Right, because we talked about that. You have signed up for school. School starts soon, and you're going to have a part time job of working, which is an amazing way to be a student. I love that. Anyways, so back to this wine. This wine. So it's from the wine rack, and it's called Basque, and it has 0 grams of sugar per liter, and so it's like skinny wine. It's like you can drink it and be skinny, but not really because it's still booze. And so the red is terrible, but the it does sound great. No, but the red is terrible, but the rosé and the white taste just like regular, really dry, like not sweet at all, rosé and white, and so they taste like regular wines. And here's the trick with wine rack wines: they're like, what? These are like $11 or $12 a bottle, so it's like cheap. It's skinny wine, and it tastes perfectly reasonable. So that's really fun and exciting. Yeah, and that's the story. Did you check out any of last week's stuff? I can do a quick recap of what we learned there. But basically, if we go back and look at week 1, what do we have? Oh, in the video, I started putting the video links to the videos into the weeks. Oh, yeah, of course, you're busy moving. But yeah, so the videos, you can actually like click them and open the videos, and it's all very fun and exciting. So here, what is the summary? The summary is that if software, so architecture is the word, so you say, what is software architecture? And software architecture is a metaphor to describe the program that you are writing. So it's nothing more than it's when somebody says, tell me about software design. It's the same as architecture, and it's the culmination of how you write your code and where you lay out your files, and all of that is just architecture. So the thing about architecture is if you have something that is well designed, it will cost less to maintain over time. And so if you are thinking about, we were working together on things like the iPad apps that you swipe through, and as those get more complex, they become harder to update. So if you have a well architected systems, oh, Pebs is back. Oh, the audio is low in my talking. Here, how about now? I've turned up the volume. It looks. Let me hold on. That's the headphone. Let me try this one. This one, I might be blowing your ears out. Is that better? That's as loud as it goes on the microphone pickup. No difference? No difference. Okay. That's strange. What about this? That's the desktop audio. This is, everything's... You didn't hear me speak into the mic? No, this is the mic that's running. Or is it? Oh. Oh, hold on. Sneaky, sneaky. Thank you. 1 second. Let me see. Add. Oh, I hope last week's sound wasn't terrible. Group audio input capture. Okay. Last week was fine. Okay, that's good. So I'm going to put that in. I'm going to choose the... I bet you something's happened with my headphones. Let me try... In Elgato Wave 3. Now, are you getting blown? You're getting blown away now, aren't you? I can see that. I can see that on my levels. Okay. Here we go. How is that? That should be loud and clear. I can see my levels are like exploding right there. Yeah. Okay. So thank you so much. Thank you for the input. Here we go. So the other thing that we got over was, so the first one is architecture is a metaphor. The metaphor is around the cost to develop new changes, new functionality. So the value of taking your time to lay things out properly and structure your programs appropriately is the long-term value to the business. And it's all about managing the complexity of the work that we are dealing with. So this is important. This one's really important. From summary from last week, where was it? It is the responsibility. It is the responsibility of the software development team to assert the importance of architecture over the urgency of features. You have to say, I know that you need this to happen, but we have to build it in a way where we can maintain it in the future. So that's the sum of last week's stuff. So that's architecture is important, and architecture. Anyways, so that was last week. This week is actually going to be long. 50 pages in this book is actually a huge amount of content. However, what I've done is because the section is broken up into, or the book is broken up into major sections, I'm actually knocking out the programming paradigms in one go. I think this might be too much, but we'll find out. So, and I'm trying to say less, but I'm working on it. So here we go. The overall point is programming languages started with something like BASIC, or something like even further before that, like machine code. So one of the key features of the machine code back in the day was that you could use what's called a go-to statement. And a go-to statement is something that allows you to take the current line of code that you're running on and jump anywhere else in the program. So you can pew, pew, pew. And from anyways, so that's, and structure, and so programming paradigms are the ways that programming languages have been altered or designed to remove the ability to do certain things from you. According to Bob, his arguments are a bit weak, but it's all about trying to deliver the concept in a way that you can understand it. So I think he takes a few liberties in order to fit this stuff into a teachable box. So the design of structured programming, object-oriented programming, and functional programming all come together around
removing your ability to do certain things at the machine level, and they help you keep cleaner code over time by doing that. There are, according to Bob, there are three major concerns in the world of our architecture and in software design. One is the functionality of the code. Two is the separation of code into components. One of the things that he says in the book, in the preface actually, is he says that code or software, unlike architecture, unlike buildings, unlike physical structures, software is not built out of bricks and mortar and drywall and wood and pine. Software is built out of software. And if you look at that software that it's built out of, that's built out of software too. So he says software is fractally complex in its nature. You go down a level, and what's underneath that level? It's more software, and it goes down, 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 down. And the point of architecture in this context, in this particular one, the separation of components, is to make software. So you build your stuff out of these pieces of software. And so what you want to have is certain pieces of the software can be swapped out interchangeably, right? And so an example of that is the version of Node that you're running. For the most part, if you are building your web page out of Node.js, you could be running version, we look at something, you would be running version 14 of Node, and you want to upgrade, or Node.js has upgraded, and you still want to be able to run your program, so you upgrade and everything just seems to work. Well, that's because the components are separate enough that you can update certain pieces of the code that it's built out of without ruining your app, or without disabling or getting in trouble with your app. The third major concern is data management. So there are every program that we design, that we build, is three things. You've got input, you've got process, and you've got output. Well, data management is a huge piece around dealing with, I guess it deals with all three pieces, input, process, and output, but data management is just one of the things. The data is part of the behavior, it's part of the output. So, quick sip. So these are the major things we want to think about overall in architecture, and each of these paradigms has an answer for each of the major concerns we have. It's actually structured programming answers a question about the function of code, and we're going to get to that in a second. We'll talk about the history, and it'll be really, I thought it was interesting. The second one, object-oriented programming, helps us with the separation of components. And the third one, data management, is well answered by the creation of functional programming. Now, I thought there was an interesting question around this, around the fact that there are some newer languages that are emerging nowadays, Golang and Rust in particular, which we've learned they impose strict controls around how you manage memory. And according to the people who talk about Go or Rust, they say it's impossible to have memory leaks in these programming languages. And so that kind of makes me think, are we moving into a new programming paradigm, or is it something else going on? I'm not sure about that, but it's just an interesting thought that I had, or at least I thought it was interesting, was according to Uncle Bob, each new type of programming came from removing our ability to do something, and Golang and Rust remove your ability to do something. So, hi, Day Adam. Thank you for joining and sending up Minecraft emojis. I appreciate that. Those are cool. So, there's a question: is that a new paradigm in programming emerging? Who knows? Exciting. So let's start then talking about what is structured programming. So you may have heard of Dijkstra's algorithm. You may have heard the name Dijkstra around. He was a programmer around, I believe it was, I mean, he was a programmer around the 60s. And he was a mathematician. He was actually a theoretical physicist before he was a mathematician. So he was working on programming, trying to figure out the problems that we have, and he came up with the idea or the solution for the problem of the complexity of programming by sitting down and using the theoretical processes involved in writing mathematical proofs, which I don't understand, but I know that there are people who go to university for 10 years to learn how to write proofs. And so I imagine they are incredibly complex, and you say, this has to be true because of numbers and symbols, and it looks like, the chalkboard in Goodwill Hunting or something. And so one of the things that Dijkstra discovered in the process of writing mathematical proofs, and in the process of, so he would take these huge programs that were pages long, and he would say, if I take the code from here to here, if I take these 5 lines and prove that those 5 lines of code work, mathematically speaking, and then I just repeat that process for each block of 5 lines of code, this will always work. Then he can say, this whole thing is going to work because everything works all the way from the top to the bottom. Well, he was doing that, and he was working at a time where the programming languages had these go-to statements. So he would be working on this tiny block, and maybe it would say, oh, go to this block down here, right? And he would say, well, I can't prove anything anymore. I can't write these proofs where you can just go anywhere in the code. So he published an article in some journal of fancy pants smarty brains, and he said the actual title of the article was, I believe, go to statement considered harmful. So he sort of lit the world on the programming. He lit the programming world on fire, and everybody was debating this back and forth, with people calling him a jerk and other people calling him a genius. And today, if you are a programmer, unless you are my age, it is unlikely that you've ever written or seen a go-to statement. So this is probably from a world that you may not understand, you may not be familiar with, because everything is effectively structured programming, because you can't just jump around anywhere you want. So, and what that gave us by writing our programming in this structured way with functions or whatever, is we can break our code up into smaller and smaller pieces. So that brings us from structured programming, we get the first architectural best practice of designing applications, which is to break large amounts of code into smaller chunks. And you will find people recommending don't have more than 50 lines in a function. You'll find people who have recommendations don't have more than, some people say don't even have more than 50 lines in a single file. So that's one of those things. One of the first founding principles of clean architecture, according to the book, smaller blocks. The reason for smaller blocks, so that you can prove that it works. So if you see 1,000 lines in a file or 1,000 lines in a single function, fix it. That's rule number 1 from the book. And that's about all that's about all you need from those 10 pages or so. I think the week is, that's probably, actually it's 48 pages, so that's probably 20 pages. 20 pages I saved you there if you're not reading along with me. The next thing that came along was object-oriented programming. And this was really interesting to me in the way that they said that they invented it. So some of you will remember from previous weeks, we talked about the way that memory works and the way that we have a stack which is a very high-speed memory that is sitting very close to the chip, very close to the CPU, and so it's super fast, but it is not, there is not a huge amount of storage there. So, and then there's the heap. The heap is like your sticks of RAM in the computer, and that's still super fast memory, but it is relative to the stack, it is quite slow. Well, a couple of programmers discovered that if they moved their function to the heap, that sort of spacious, plentiful memory that they could work with, spacious, plentiful, slow memory that they could work with, they found that the variables that they created inside the function were still there. And then that was effectively the birth of object-oriented programming, because they started deciding that, well, we just write everything as a function. So we write this. So an object is just a function, and the object or the function has variables inside it, and that what that wound up doing, because an object that has variables inside it, that has additional functions inside it, can be passed around as a function parameter. So let's see what else. What are my notes in here? You could store local variables within the function; they'd stick around. So the object this within JavaScript, you know how you can say, if you're working in JavaScript, you can have functions attached to your this object. What's this bunny? This bunny is drinking a soft drink. Well, that's a lovely bunny as well. Thank you, Adam. So the functions in JavaScript objects, this object can have functions attached to it. It can have variables attached to it. You can pass it around. So these were not particularly compelling or stuff. So OO languages allowed a plugin architecture to be invented. So by allowing us to pass around to create, by allowing us to create functions that contained the variables and other functions, we can move all of these things into their own files. We can move them into their own libraries. And by doing that, we can actually publish these libraries separately. So we have this self-contained block of code. We move it off to the side, and we can ship that off to another team to work with. So some other group of people are working with that, and they update it independently. And that's how our entire programming lives work nowadays. You don't have to write Node, for example, from scratch. You don't have to write leftpad because you just pull in the library via npm. You don't have to write Babel. You don't have to write Webpack or Gulp. You pull these things in, and each of them is deployed, and updated independently. So last week, we spent a lot of time trying to discuss dependency injection. And all of this is around finding a way to make sure that things can update independently of each other. Okay? So by updating things independently of each other, this is the thing that we call dependency injection. So if you pass the function that you need to call to your controller, to the thing you're working in, you can change the function that's coming in, as long as you know that it has the items that you need. So I went around looking to try and find a really good real-world example of what dependency injection is, and it was, imagine you're in a restaurant and you want to order a hamburger. So you go to a food court and you go to all of the restaurants and they hand you their interface being an iMenu, right? So you've got this stack of menus. If the menu has a function on it called order hamburger, you know that this is one of the restaurants you are able to use. And that would effectively make all of the restaurants that implement I have hamburger a valid restaurant to use. And so dependency injection is that same sort of thing, where the restaurant itself is interchangeable just so long as it implements the thing that you want to order. In this example, a hamburger. So if you are trying to think of that in the context of an application, in the context of programming, you might, instead of going into your code directly and calling, let's say we have a code with a database in it. The code has and our database is MongoDB, okay, or it's MySQL. It doesn't matter what database it is right now for the example. So you can either write the code to call Mongo functions directly, or you can pass in something. You can pass in an argument that has save my data. Okay, if you call the Mongo function directly versus passing something in that has a function called save my data. Well, if you ever want to change the database, if you call it directly, you've got to change that code everywhere across the application where it happens. But if you just pass in an object that has the save my data function, you actually just have to change it in the one place where that save my data function exists. So that creates what's called a decoupling, right? Because you're splitting apart your objects into different places. So what do we get if we separate the code if we separate the code far enough, we can deploy it independently. We can deploy DLLs or API if we have APIs, and we've seen this in the distributed computing talk that we watched a couple of weeks back, where the sales department launches their API and the interaction department launches their API and accounting launches their API. And each of those, you can deploy them separately when we separate these things out. Oh, hi Rajat, good to see you, and good to see you on YouTube. Thank you. And then the other thing that's really interesting about that system where we separate these components out is they can be developed by different teams. And what do you get when they can be developed by different teams? You get scale. Your projects, you can have more developers, which should mean that you are able to develop faster and better over time. So rule number two, separate things out because you want, as much as possible, because you really want to be able to break off chunks and develop them independently. Next up. Okay, this isn't as long as I thought it would be. We're going to have a short day. So the last one is functional programming. And functional programming is still the hardest one for me to wrap my head around. I really have to go out and learn a functional programming language to really get this. But one of the things that comes out of our understanding of functional programming is that except under very strict conditions, you cannot reassign variables. So if you consider something like React or something like Angular, all of the views in Angular and all of the views in React don't actually change the data themselves. Oh, somebody's speaking down below the line. Who's that? Ramda.js is a good intro. Is Ramda.js good functional programming? That's really worth looking into if it is, because I would love to. Yeah, oh, great. I would love to learn that a little bit more. So the point is you can't reassign variables except for under specific conditions. And Uncle Bob, Robert Martin, the author, says, why would you be concerned with where variables change? Well, it's because as you move, it's like Lodash and underscore, but done properly in functional programming, or so the internet says. Yeah, so that's well, we'll take them for the word. Internet's very rarely wrong, right? So all race conditions, deadlocks, concurrent update problems, right? And we talked about, Kreshnik is really smart too. I like Kreshnik. Concurrent, because we talked about the memory update thing with threading systems. So all of those problems happen because of changing variables. It's sort of definitional, like, right? The variable, the race condition, all of this stuff happens because of changing variables. So if we engage in this thing called segregation of mutability. So that's we separate the places where variables change into very specific parts of the code. So maybe all of our HTML doesn't have anything that changes code. Well, suddenly, if we have something like a race condition deadlock, concurrent update problem, something related to changing a variable that's not working, all of our display code is, we don't have to look there for the bug. We can go straight to the places where code changes, which further reduces the amount of surface, I guess that's the surface area of where the problem could possibly be. So well-structured applications will be separated into components that change variables. Wait, oh no! Holy sh... Pete's sakes, give me a second. Audio input capture. Audio input capture right here. Okay, there we go. This is amateur hour, guys. Team, friends, everyone. This is amateur hour. Anyways, so I know. So as I was saying, yes, I have been sharing my screen the whole time, and my apologies because it just hasn't been on the screen itself. But I've been working off of a pretty robust set of notes, and it would have been way easier if for you to follow along if I had these up on the screen. So there we go. So here we are. We were saying the well-structured applications will be segregated into the components that change the variables and don't change the variables. So the HTML, you would have your HTML is all off on one side. Oh, good. I'm glad you're getting it. That's important. And that's it. So when you're looking for looking to solve problems, if you have places where data doesn't change, you know that your bug cannot possibly be there. He spends a long time, and I didn't like this part of the book so much, but he talks about, as an example of variables that never change, so they're values that never change. If you had a truly segmented, a truly functional system, you would have something where you start with an initial value, and then you just take you change the difference. Who's that? John! Hello! Thank you for coming back. We're actually nearing the end. These are going to be shorter, I guess. So he calls this thing event streaming. And event streaming is a system where you start with a value and you don't change the value itself, but you record a list of the changes to the value. So if I had the number 5, my bank account number, let's say I have $500 in my bank account. If I withdrew money, I would not update the number in my bank account. I would record -10. And so if I wanted to get to the end of, if I wanted to get my current bank balance at any time, I would just start from my initial value and apply all of the changes that happened over time. So that is an exam. And so I would have this transaction log. And that's what happens. That's what Git is effectively made out of. You have your initial commit, and then you have your change set that you apply on top of that initial commit. And it just goes boop, 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 boop. And if you want to get to the point where you are at any given time, you just roll through that changelog history. So that's an example of an immutable system. The Git system, there are, let's suspend disbelief because there are parts where it can actually change. But Git really is, in a normal sense, it's considered completely immutable because everything is recorded for all time as you go. So that's, anyways. So, and I feel like in terms of the book itself, that was pretty tangential. So that's the story of the week, though. So the foundations of architecture, which are the programming paradigms, are all based on removing a programmer's ability to do something in order to impose discipline. Get push -4. Yeah, okay. So it's changeable in that respect, but I'm talking about normal. Initial foundations of architecture, programming, all based on, so the function, let's play this back. Functional programming is about effectively removing your ability to change variables. The object-oriented programming, he said this up at the top, he says object-oriented programming prevents the programmer from indirect control. And so, and this all falls under the object-oriented thing of encapsulation. You have public fields and private fields. You can't call anything or access anything on the private fields. And so object-oriented programming, by marking things as read-only, by, in JavaScript, the const, right? You cannot reassign the value that is attached to a const. These are types of things that prevent us from accessing and changing things that we can't. And then the first style of programming prevented us from using go-to statements. And so those three things together are what the author, Bob Martin, puts down as his understanding of what the foundation of a programming paradigm is. A programming paradigm is about removing things, removing the ability to do things in order to keep our programs more structured and to make sure that we just design them with rigor. Functional programming is about changing state in a controlled way instead of having state change throughout the whole code base. Yeah, and so that's exactly right. It's by doing it in this, and so sort of in his writing, it's quite. I think he kind of shoehorns it in to this removing things, but his removing the ability to reassign, I've never heard it described that well, by the way, Pebs. That's really good. That is by adding that structure to where you can set variables. I should be sitting here. So adding the structure to where you can set variables, we're separating the places where bugs can be. And that cuts down, and that discipline cuts down on cost over time. And his position is that all of those rules of architecture, each one of these programming paradigms was invented between, I think, 1966. Object-oriented was the last one that was invented, and the other two were invented, I think, in 1964 and somewhere in there. So the author's take is that there are no new programming paradigms that are going to be invented, because if they would have been done by now. The only thing, it's nice that John showed up, because he's our resident Rust expert. So my thoughts, and John might be able to tell us a little bit more about what his take is. So if Golang and Rust both impose strict controls on the programmer to prevent them from inadvertently creating memory leaks, does that count as a new programming paradigm? In fairness, I had these in my notes already. So that was the only thing that I was wondering about, and I'm really glad you're here, because this was the thing. Uncle Bob's take is that the invention of structured programming removed the go-to statement. The invention of object-oriented programming removed access to the functions you're not supposed to touch. And the invention of functional programming removed the ability to change variables through the majority of your program. So does Golang and Rust count as a new programming paradigm because they remove some form of memory access? I don't understand enough to know if that's true, but is it possible that these are an entirely new paradigm in programming? Maybe. So Okay. They tried, though. They tried their best. Maybe we have to think of a new paradigm name for it, though. Anyways, so that's the extent of the notes for the week, though. I don't know that I don't have any videos on this stuff. I'm just going through the notes in the book, but that's all we have, and maybe short videos will do better. Maybe that's okay. Definitely leak memory. Yeah. Anyways, so there it is. Rust borrow checking system is quite unique. I don't know if it's a full-fledged paradigm, but it's not far off. So there's a question. Let's just do it. Let's just do it right here and now. Rust is a new paradigm. I have not finished Philosophy of Software Design. I am reading it alongside. Have you? I have it right here. Hold on. Oh man, maybe you should be giving presentations there, Pebs. I would love to. I would love to hear a summary of it. Yeah, you get more power, clarity, or something. You get something by taking away. It's funny, right? Because And I think that's his different take on things from Clean Code. It will be in, yeah, I will. I haven't read Clean Code yet, but I have it here also on my desk. And this one, the Clean Architecture one, is going pretty well at work. So we're reading it at work together, and I think today was our first. We did just the first 2 chapters today, and I got the sense that people really enjoyed it and sort of learned from it, and it was really fun. So that was good. So, yeah. Anyways, it's a short week, I guess. Next week is moving into the first half of Solid Design Principles, SOLID, the stuff like that. And yeah, that's the story. So I'm just watching for chatters, but there we go. Okay, we're gonna pop off. Oh, what's this? Thank you. We'll talk to you again soon. That's all right. Next week, solid. You'll have lots.